Here is our today's speaker. Gwendolyn Stripling is an artificial intelligence and machine learning content developer at Google Cloud. She holds a Ph.D. Dr. Stripling is the author of the widely popular YouTube video Introduction to Generative AI and of the O'Reilly media book Low Code AI, a practical project-driven approach to machine learning. She is also the author of the LinkedIn learning video Introduction to Neural Networks. Dr. Stripling is an adjunct professor and member of Golden Gate University's advisory board of Masters in Business Analytics. Dr. Stripling enjoys speaking on AI/ML, having presented at Domination University of California's Browski School of Business Analytics, Golden Gate University's Agano School of Business Analytics, and numerous tech conferences. We are delighted to know and meet Dr. Stripling in this session. Welcome, Dr. Stripling. Over to you.
Thank you, Kirthikka. It's a pleasure to be here. I was really excited when Lindsay reached out to me on LinkedIn because I thought, wow, this would be a great time to talk about some excerpts from my LinkedIn learning class, the YouTube videos, and also from the book, because I think it's important that people understand that you don't have to code from scratch. There are different tools now that are being used that are very powerful. And I just wanted to share that. So I was really, again, really excited when Lindsay reached out. And with that, I am going to go ahead and share my screen. And I was watching in the chat and listening to Kirthikka as she talked about what people were interested in or their expectations are or were for the course or for the talk today. And I hope that I can meet some of those. I hope that you find something in here that speaks to you. And if you'd like to reach out to me on LinkedIn, please do. If you have any other questions or just, want to chat about where you are in your journey, I'd be happy to do that. All right, so I'm going to skip this slide because of the introduction already being presented. So I'm calling this a tutorial, if you will, but it's really just me talking about and sharing the deck that I presented at the Open Data Science Conference in September. So the objectives are really this, is to explain the machine learning workflow, to use AutoML to build and train an ML model without writing a single line of code, and to use Keras to build and train an ML model as well. So essentially, I will show you one use case, one business problem, and show you two different ways how to do it. So imagine that we have a solar energy firm and they have a modest media budget and they need to evaluate which media channels offer the greatest number of benefits for the least cost. And we have these junior analysts and they have no coding background, but they do have domain experience. And so they've been asked to develop a marketing plan to increase next year's product sales. So the business, the business goals are to predict sales volume generated based on the money spent in each media channel. Also to forecast any future sales based on the media channel's proposed budget. And then to determine the relationship between advertising budget and sales, and determine which media channel contributes the most to sales, and determine if the model can predict any future sales accurately. So here's our project data set. It's a data set that is based on data taken from an introduction to statistical learning with applications in R by Daniela Witten, Gareth M. James, Trevor Hastie, and Robert Tibiscirini. And it was produced or published in in 2021, and it captures the sales revenue generated from advertising for particular product channels. I've taken this data set and I've actually modified it to include a digital variable. And this digital variable now is a part of that data set. I've also increased the number of records, if you will, from I think it was 1,000. Now there's about I think there's like 12,000 or something like that. I'm sorry, I'm it's still a bit, although it's 11 o'clock here, I'm still kind of waking up. I've had a very long month already in the push to get Q4 done with all of my deliverables this quarter. So my apologies for a little bit still kind of waking up here. Anyway, I've increased the number of rows in the data set. So I'm going to start with what is machine learning. And I just want to start here because I never make assumptions as to where people are in their journey. You know, even though I've been on this path for a while, I still like to go and look at what others are writing about machine learning and AI. And I still like to see how others are telling the story, because there's always something that one can learn. And so when we talk about machine learning, we need to talk about AI, and they are not the same, right? Artificial intelligence is a discipline, right? So the differences are in terms of it's like physics, if you will. And if you can see, if you look here in this diagram, you have AI, ML, and then you have deep learning. So AI is this discipline, and like physics, and it allows you computer systems or agents to learn and act autonomously. Okay, and within this discipline is machine learning, and machine learning is a subfield of AI. So AI is the theory. A more formal definition is AI is the theory and development of computer systems able to perform tasks normally requiring human intelligence. And so it's a subfield. Machine learning is a subfield of AI. So machine learning gives computers the ability to learn without explicit programming. And so what do we mean by that? Well, we have two major types of machine learning. There are lots of more algorithms, which is beyond the scope of our class or our talk today. But I like to, sort of start with unsupervised models and supervised models. And so when we talk about supervised learning, if you've heard this term, what this means is we're looking to learn from past examples or historical data. And we want to learn from that historical data to predict future values. And so in this example here on the slide, you have a restaurant owner who's interested in the tip amount. Well, why is that important? Well, this person wants to know how much different people tipped based on order type. If the tip amount, how this person has a staff and they're trying to figure out ways to improve customer service. And if they can figure out that when people are getting the food delivered, they're putting into DoorDash the tip amount, if you will, or an extra tip, then they want to know what they can do to improve the service. Can we get there faster? Will that improve the tip, right? Can we add extra little food, for example? Will that improve the tip? So these are different sort of examples of why you want to have a supervised learning model. And here the data is already labeled, meaning that think of labeled data as a spreadsheet with column headers, right? Like tip amount, order type, picked up, delivered. Those are labels. And so when we say labeled data in machine learning, we're saying that data already has a label on it. So supervised learning, again, is just to find out, using historical data, how we can predict future values. That's very different than unsupervised learning. in supervised learning, there are no column headers. It's unlabeled data. You're just throwing it into the model, and you're looking for clusters of things. And you can list, you're looking to see how things, how the raw data is kind of naturally falling into groups. And in this example, you're seeing income versus job tenure. So, you know, the longer I'm at the company, does that, you know, how does that sort of, where am I in that cluster in terms of my income? And so this is an example of unsupervised learning, where again, no label data, and you're looking at clusters or groups of data and how it sort of falls, where it falls into groups. So if you look at this from a sort of a workflow perspective, in supervised learning, your data comes into the model, then there's a prediction, which is Y, which is the output, and there's error. When we talk about error in machine learning, we're talking about you put in your initial true value, and the model predicts the output, which is your predicted value. And that difference between the predicted, the true and the predicted, that is called error or lost or cost. There's many different terms, but really it's that delta between the true and the predicted. And so that delta, that difference is what is called error. And what the model is going to do is kind of say, okay, I want to kind of get the true and predicted closer together. I want to reduce that error. And unsupervised learning, you put it into the model and it just gives you some examples. So you've also maybe heard of deep learning. And so in machine learning, you have different types, you know, you supervise, I've mentioned unsupervised reinforcement. As it sounds, it's you're learning by reinforcement. We also have another subset of ML, which is called deep learning. And in deep learning, we're using artificial neural networks, and we're allowing them to process more complex patterns than traditional machine learning. We may have a ton of more variables that we're interested in, right, in terms of their patterns. And we need more processing power. We have this complexity. We have these multidimensionality of all these different variables. And so you probably want to use an artificial neural network. And this is what one looks like. So in this artificial neural network, there are many layers, right? This one is a simple one, right? And if you ever heard the term hidden layer, that's simply that layer in the middle between the input layer and the output layer. And so you have these nodes, these input nodes here, where all the data just comes into this neural network, and it's based on the biological neural network in our brain. We have these nodes and these synapses, these neurons and these synapses, and they fire, and then we kind of, you know, we learn or we remember something or we're thinking about something. And so the artificial neural network is based on that same kind of reasoning. You input data, it sort of sums up all the connections that it's receiving, and then it outputs something, and then it's learning, and if it's not right, it goes back and try to, you know, make it right, if you will. But neural networks are really powerful in that they can learn both, they can use rather both labeled and unlabeled data. So I do have some additional slides on neural networks, so I can talk more to that later on in the talk today. So again, really simply, in classical supervised and unsupervised learning, you have training code, you've got your labeled data, it comes into a model, and then you're going to either do three things. You're going to either predict something, you're going to classify something, or you're going to cluster something. That's it. Okay, so our problem today. I mentioned that we have these junior analysts, and they have been asked to predict Sales, we're going to use a simple linear regression supervised learning model, but they don't have any coding experience. Well, before we start into the business case, I wanted to take a step back and say, well, what do they have to do to make this happen, right? Well, there's a machine learning workflow. And at a high level, you identify the problem, which we've just done, right? We need to predict sales. They need to collect the data. It has to be cleaned, explored, transformed if needed, find an appropriate model. We've decided which one we're going to be using, supervised learning model. It needs to be trained and evaluated and tuned and tested, and then deployed and maintained. We're not going to go through the entire workflow in this session. Actually, each of these could be a complete talk in and of itself, but I'll be focusing on some of the high points here so that you get an opportunity to see how this worked from an AutoML perspective and from using Keras as well. Okay, so at a really high level, the machine learning workflow is really about three things. You know, it's about data preparation, model training, and model serving. And believe it or not, there are three ways you can accomplish this particular business problem that we have, or any business problem. You can either do AutoML, which is automated machine learning, which means you can do that entire workflow without writing a single line of code, essentially, depending on your tool set. You can use BigQuery ML, which is a Google product. If you know SQL, you can actually use SQL to do machine learning. You don't have to learn Keras or TensorFlow or PyTorch to do machine learning if you know SQL. If you know SQL, which is structured query language used to extract data from databases, you can actually build really good models, and it's very powerful as well. Again, that would be a complete new talk in and of itself, but it works really, really well. The other way that you can achieve this goal is to do custom training. And when you talk about custom training, you're talking about writing code, right? You're talking about basically having everything in a Jupyter Notebook, right? So, and we'll be looking at that too as well. So first, we're going to use AutoML to build and train a model, because, you know, I showed you those phases of the workflow, and it can be very time consuming, right? If you've ever seen the entire pipeline of code from loading the data to actually deploying and monitoring and maintaining the data, there's a huge amount of code, right? And so what AutoML does, it allows you to actually address a major part of the ML workflow. Phase 2, for example, cleaning the data, exploring the data, transforming the data. It'll find the right model, using neural architectural search. It'll do all the training, do all the experiments underneath the hood. It'll provide you evaluation metrics, shows you what features are important. It does take a while to do this. So depending on, how large your data set is, it could take hours, right? But it does work. And my understanding from what I've read is that 80% of organizations use AutoML first as a baseline to get baseline metrics. And then they may tweak it here and there, but they basically use that more than writing code these days because it's so much faster. Because even though it takes time to do all the training, it is still so much less time than having people having to do all these separate pieces, right, of coding. So with that, I'm going to go through a few other things. So what I've done here is just taken the workflow basically and shows you what it's going to look like when I go into the tool, which is Vertex AI. So the first phase is data collection. Believe it or not, I'm just going to upload a file from my computer, and I'm going to be, again, using AutoML. I'm going to upload it. I'm going to put it into a cloud storage bucket, which means that consider it like a drive, if you will, in the cloud. So it can just store it there. And I'm also going to, if I wanted to, if I wanted to do, and I needed to, because I know SQL and that's what I want to work in, I can actually put that that CSV file and make it a table or a view from BigQuery. So that's very powerful as well. The other thing about the ML workflow is you collect your data and then you want to take a look at it. And this is called the exploratory data analysis phase. And so here you'll see when I'm in Vertex that I will be able to load up my data set. It'll take some time to generate statistics, maybe about 3 to 4 minutes. So I'll go ahead and show you one that I've already done. But what you'll see, though, is that it will perform the EDA. It will tell me how many columns that are in my data set. It'll tell me how many rows. It will tell me if I have any missing values for each of my features. It will tell me any distinct values. AutoML will also do something else. I can click on actually one of these columns here, the feature digital, for example, and it can tell me my stats. It can tell me what the mean is, what the standard deviation is. And you will see that when I do this in Python, there's some simple coding, but there's coding. Here, AutoML does it automatically. So I'm looking at the distribution of this particular feature from a statistical perspective. I have 494 instances where sales are between $3 and $44. I have 52 instances where sales are between $400 and $17,000, for example. Same thing with newspaper. Again, each of these features are automatically given to me, in terms of looking at their statistics. So the other thing is data pre-processing. So data collection, you collect your data, you explore it, and you pre-process it. So there's different types of pre-processing. I'll hit a few of those in this particular slide, but also when we're doing looking at the part of the talk, you'll see some other ways you can do data pre-processing. But typically you're looking at normalizing or denormalizing the data, or standardizing the data. So here I've got 2 tables, for example, product and sales. And for it to be more efficient and optimized, I want to actually join these 2 tables together so that this is what goes into my model. And of course, this won't be, these ID numbers here or strings, these are words. And so I'd have to do what is called some kind of string manipulation to make them into numbers, and it's called one-hot encoding. But all of this is done by AutoML. So any numeric values I'm fine with, but sales will be fine. It'll go into the model just fine. It'll be turned into a numeric value, an integer or a float. But the other values here will have to be one-hot encoded, and that's a lot of coding for all of these separate ones. Even year looks like a number, but it's not a number. Year actually is it's not considered a number from machine learning purposes. It's considered a category, right? So, but again, all this sort of pre-processing I'd have to do in the code, where AutoML just does it automatically for me. And then build and train a model. AutoML is going to do something really amazing for me. It's going to go ahead and just say to me, okay, you've given me your data set, you've analyzed your data, you've decided if you want to keep any features or not, you've if there were missing values, we could have dealt with that, but you had none. You can just go ahead and train your model. And I'll say, okay, great. Let's go ahead and train my model. And after it's trained my model, which will take some hours, it's going to give me some metrics, where I can evaluate my model. And it's going to give me, and I have another slide that shows you what all these are, but it's going to give me these metrics. And I'm looking at root mean squared error here, or R squared, depending on what my use case is. It's also going to give me something, what I really love is called attribution, or how important is that feature to my target, which is sales. So if I look at this, I would assume that digital would be more important to sales, would actually predict sales more in terms of the weight it would have on the model. But apparently that's my assumption is incorrect. Radio has more influence on sales than digital, and digital has more influence on sales than television, and newspaper has absolutely no influence. And so if I'm one of those junior media analysts, I probably want to, in my proposal to the team, say, we might want to consider just not doing any kind of newspaper advertising and putting that money toward TV or digital to improve sales there. And then the other part here is the prediction piece. So AutoML will give us the ability to pop in a number here and hit predict. I had this set up on my work machine, and I have to see if I could do it on my demo today, because long story, I had some computer issues earlier in the week. So this is my personal machine, but hopefully I can still pull that up. But I think this really shows the power of AutoML here. I can actually put a value for sales. I can say, rather than having $224 for the budget, let's just put $500 to sales and then predict. And actually, when I click predict, I will get a prediction interval here that will show me what sales would be. And I can be basically 95% sure that that will be the amount if I were to increase sales, to $500. And so that's very powerful. To code all of this, it's quite extensive, right? AutoML does it for me automatically. So just to kind of go back really quickly, just by looking at the slides, I can just tell, for example, the relationship between advertising budget and sales. I can kind of see which features are more important and that contribute to sales. I can also forecast future sales by that prediction slide that you just saw. And I can also predict sales based on money spent in each media channel. So let's take a look at how this works. So I'm going to use Vertex AI for the no code session, part of the session here. These junior data analysts, they have no coding background. And AutoML is for those citizen data scientists. It's for data scientists, it's for data engineers, it's for business analysts, it's for anyone really who wants to go in, load a data set in, and just see what happens and play around, because it's very robust. So let me go ahead and go to my demo. Okay, so this is when you go to Vertex AI, you get this dashboard screen, and typically you have to enable your APIs, but I've already done that. So I'm just going to get started. I'm that junior data analyst. I'm going to say, all right, I'm going to go to data set. And I need to create a new data set. And I'm going to give it a name. I'm going to call this media channel sales, I'll call it 12.9. Okay, that's my data set name. And I'm going to scroll down. And here, now we can talk a little bit about machine learning from a practical perspective, right? So I talked about supervised learning and unsupervised learning. And I was I was primarily talking about text data, structured data, right? Rows and columns. There's many different types of data. There's image data, right? There is text data. There's unstructured data. There's emails, blogs, product reviews. There's video, right? And in video, we can, if I wanted to do video recognition, if I wanted to do video classification or video object tracking, I could actually load that video in, and AutoML would do all of this for me. And similarly, I'm going to go back to text. If I wanted to classify text with a single label, if I wanted to classify text with multiple labels, if I wanted to extract entities from text, AutoML will do that for me. And to go back to image again, if I wanted to classify an image with a single label, if I wanted to classify it with a multiple label, or if I wanted to even detect an object, AutoML would do that for me. So, but we're talking about regression, right? Using structured data. And so with regression, we're going to predict a target column, which is sales. And we're going to be able, go down here. I'm going to have to reduce my screen here. There's lots of things on the bottom. I'm on my laptop and I do apologize, but there's like all this Zoom stuff at the bottom. Let me just put it to the top so I can see. Okay, great. All right. And move this one too out of the way. Here we go. Okay. All right. So I have tabular data. It means it's in rows and columns, either from a spreadsheet, from a CSV file, from a separated value file, a tabular file. It has labels on it. I have a region that's defaulted. That means that throughout the world, there's these data centers throughout the world. You want to, as a best practice, have multiple regions if you have multiple locations of business. But for me, I'm a small business owner. We're a small solar energy firm. We just need, a centrally located region, and that's all we're going to choose. And so that's why I'm choosing central as a default, and I'm going to say create. I do have some advanced options, but I'm a junior data analyst. I just want to go ahead and load the data and just kind of point and click. So when I do that, you see that it says media channel sales. It hasn't loaded yet. I have to show it where the file is, but what you see here is there's a little tutorial for this junior data analyst saying, here's a housing, if you had a housing data set, this is what regression means if you wanted to predict, a numeric value, for example, the size of the house based on the number of bedrooms. And it says, for example, this is a classification model. Do you want to predict whether the house is near the ocean or not? So just kind of teaching you too, as you're kind of clicking through here. But for us, we know we have a regression model. We're going to be uploading a CSV file from my computer. I could get it from cloud storage. I could get it from BigQuery, but I'm just going to go ahead and select it from my desktop here. There it is. And I just click open or select, and I scroll down. Now, I've already created a cloud storage bucket. If I didn't have one, I could just browse here and create a new one, select, give it a name, and I would be happy. And in that path, we'll say, okay, there's a bucket where you can store your cloud storage, your file. And so basically what happens next is the file data will be the CSV file will be uploaded to cloud storage, and all the associated associations with your data set will be made. And I'll just say, great, continue. So while that's loading up, it gives me really quickly this screen, but you'll notice here I have generate stats. So I'm just going to go ahead and start that because it takes a while. But I'm going to go back up here. And so right away, it tells me my properties immediately. Well, it's a CSV file. And this is the location. Great. Now, even now, without even clicking generate statistics, I could click train new model, right? I mean, I'm a junior data analyst. I'm assuming that my data analyst and data engineer, I'm a media analyst. I'm assuming that my data analyst and data engineer have vetted this CSV file. So why am I even interested in the stats? I would just basically click train new model and start training, right? But I do want to show you what it does when it generates stats. So let me go back to a data set that's already been generated. And here is what you saw in the slide before. My digital feature, my newspaper feature, radio sales is my target, TV is a feature. I have no missing values. And if I click on digital, there's my EDA, my exploratory data analysis. I can just kind of hover and I can see all the distributions of this feature. That's the same for each and every one of these, right? So again, no coding at all, right? At all. Everything's done for me automatically. So I'm going to go ahead and train this new model. And I'm going to use other. If I were to use pipelines, it's more advanced. I would have to create this AutoML pipeline. And that's something that I think is out of scope for us because I want to talk about pipelines and why they're important and how we can use them. Again, our hat today is that we are either a citizen data scientist or a media analyst, someone who just needs some baseline metrics. So we're just going to click other. And basically, there are just 5 steps. You can see that my data set was carried over. I'm going to choose regression because I want to predict a value versus classify whether or not there were sales or not, for example. I'm going to use AutoML. I could use custom training. And for those of you who have more experience, you want to have more control of your environment in terms of training. You can actually split the data. You can actually control more of the process. So I'm going to actually just not click that because I want to just keep it really simple. So let me just kind of go back. But if you were interested, for those of you who've done this, there's a training validation test split. You can choose, right? AutoML will choose for you if you don't choose. So let me go ahead and go back as if I'm a junior data analyst. Then I go to AutoML or media analyst. So data set name, regression is my objective. AutoML, I want AutoML to do everything for me. I don't want to write a single line of code. I don't need to. I'm going to put in the description, predict, media sales. My target column is sales, and it's still showing the advanced stuff. I'll show less. And I'm just going to go continue. This is a new feature here. Excuse me. That's just come out in experimental phase. It's called Add Features. We have a product called Feature Store that's a part of Vertex AI. You can use it to create a feature store. Again, for our purpose, our scope, we're just going to continue. It's very powerful if we did need that. And here, I just want to make sure, right, that that I am indeed going to predict sales as my target, and that if I didn't want to use newspaper, for example, knowing that already that it has hardly any influence on sales, I could even actually remove it, but I don't want to. I'm just going to leave everything as it is and continue. And then here is the final final step. When you have your data set, you have your model, it has to be trained. It has to be trained on a VM. You need compute resources. And so I'm just going to give it one node, right? And I have clicked enable early stopping. This is part of what is called a hyperparameter. If I were to code this, this means that that model is going to just go through so many iterations. And when it finds the best performance metric for me, I'm telling it just to stop and don't charge me anything else. And so that's why I've enabled that. And I think that's it. Okay, looks like I missed something. My apologies. Let me go back here, make sure I have everything. Regression, yep. ML. Continue training and compute. And then I would just start training, right? So I do have a trained model. Let me go and find that one. Here. It takes a few hours. You get an email when it's done. And I think this is the one that I did last night. Yeah, or early this morning, actually. But I'm going to take the one that I did in October. So I'm going to go here. But there's one I did just this morning, and it failed because I stopped it. It wouldn't have been done in time anyway. So I'm going to use the one that I've already done. Okay, so here is the results of the training. And I could deploy the model and test it, right? I don't have an endpoint set up, but if I did, you could then see the prediction table. This is my personal account, my personal Vertex account, and I'm always charged because endpoints cost money. On my work laptop, I do have the prediction set up with endpoints because I am not paying for that. So I don't have that set up, but you could see from the slide that if I were to deploy the endpoint, it would look, once I deploy the endpoint, let me get this out of the way. And I wanted to predict, it would look like this. And you've just seen this just a second ago here. Okay. So if I had an endpoint set up, all that is basically putting in a few values and then say deploy, and it will deploy. But when it does that, when it's deployed to the endpoint, then I can test my model. Then you would see that I could do digital, TV, etc. When I presented this at Open Data Science Conference, I did use my work laptop because I was presenting live, and I can't do that now because I'm presenting and it's being recorded, right? So I can't use my work laptop to present. But again, when you play with this, you can get a free account, right, for Vertex AI. And when you play with this, just make sure that when you're done with your prediction, that you undeploy the endpoint or you will be charged. Okay. I forgot a few times, and for my personal account, I've had to pay. So you deploy to the endpoint, you do your predictions, and you undeploy so that you're not charged any additional fees. All right, so back to Vertex AI. And let me move this back up here. Okay, so, but although I can't predict on my environment right now, I can look at feature attributions, and I can look at evaluation metrics, really, which is what I'm really interested in as well. So again, as you saw in the slide deck, feature importance, radio, TV, newspaper. If I hover, it shows me how important it is. And believe it or not, I'm done. My data set was loaded. I performed exploratory data analysis using AutoML, did that for me. I saw the all of the features. I could select each one of them and see a little bit of the stats on them. I trained my new model. It's going to take a few more hours. I'm trying to reserve resources on my personal computer because I'm paying for everything now. But you saw the results of the evaluation from a prior model that I trained. I'm done. I can now, as is my partner and I, as a media analyst, we can create a report. We can actually fill out we can actually complete those questions that that we had asked earlier. So let me go back now to my deck. And that is it. I did not write a single line of code. I was able to determine whether or not there were missing values. I was able, if there were, I could have changed them. If there was a zip code as a field that was shown as numeric, I could have transformed that in the GUI by saying, no, it's categorical. There's a drop down for that. There's all these things I could have done, but I could have done all those things without writing a single line of code. In terms of data pre-processing, it did all of that for me. In terms of building and training, it did all of that for me. I could deploy it and also serve it without writing a single line of code. And so that's Vertex AI AutoML. Now, let's take that same use case and let's build and train a simple ML model, but using Keras. So you saw that in the Vertex AI AutoML, there was an advanced section for for training, like you could change some things, right? That's great. But if you want to be able to have a little more control over your model, you want to be able to code a little bit. And it doesn't take a huge body of knowledge to do this, to use a simple Keras sequential model. And that model is actually quite powerful. So here is the architecture, if you will, for our features and for our model. We have the input layer. Now I have here, as you can see it, digital, TV, paper. Let me go ahead actually and move this to here. And then radio. And then here's my output. So now the question becomes, well, why am I using a Keras sequential model? I mean, there's all other kinds of things, right? Well, I believe in being efficient, as efficient as I can. And I also believe that why should I write a whole bunch of code when I do not need to? So what I've done is, and I also do this in the book, I say, well, this is what a neural network would look like in Python, how you would code it in Python, right? Starting from here all the way up to the second column, right? And this is what it would look like if you were to use the Keras functional API, which is a little less than what we just saw here, but it's the functional API. You can have a lot more control, more customization, right? But I prefer the Keras sequential model for my baseline projects. Why? Well, 6 lines of code. That's it. After you've done your data collection, your exploratory data analysis, your data pre-processing, just 6 lines of code. And so let's quickly, I'm going to just, for those of you who haven't seen this before, I'm just going to give you a high overview. And for those of you who have, it's just, you probably can just kind of tune out for a second. So the Keras sequential model has 6 lines of code, right? And so what I decided to do, and this is the new part that I've added last night, very late, I was thinking to myself, okay, well, I can show the sequential model. I can go into Jupyter Notebook and, show them how we could do data collection and data analysis, data preprocessing using code, right? But what if I asked help from a large language model such as BARD, or chatbot such as BARD? How could that help me? So I tried this last night, and this is the first time I'm demoing this. I'm going to generate low code using generative AI. First thing I thought was I would go to BARD, for example, and I would say, show me how to load data into a pandas data frame, right? Then I said, okay, show me how to data analyze these features using Python. So let me show you what happened. This is very exciting because before I would just take my prior notebooks, right, that had all the code that I needed, and I would just do duplicate it and change some things. But I thought with code generation using generative AI, what if I gave BARD an instruction, a prompt, with my features, what would it do? I was surprised and I was impressed. So let me show you. I'm going to go now to BARD. Okay, and what I've done is so this one is show me how to analyze these features using Python. So let me just go to BARD here, and I'm going to see if I can remember what I just read. Just show me how to, I think it was pre-process, how to data analyze these features. Okay. And the features are digital, television, newspaper, and radio. Now let's see how it does. And it says, here's how to analyze the features, digital, TV, newspaper, and radio using Python. And I'm going to scroll down here. Okay. First, it shows me I have to import my libraries. That's true. I've got to import pandas as an alias called Ph.D, which allows me to do my data load and visualizations, manipulations, matplotlib for plotting, Seaborn for more advanced visualizations, NumPy for math, sklearn for pre-processing with my standardization of the data and normalization. Okay, it's giving me a train test split. That's good. Okay, and it's giving me my statistics too. Data.describe, my data and feature distribution, shows me how to plot the correlation matrix. It basically is giving me everything I need for EDA, exploratory data analysis, and data pre-processing, missing values, whether or not something is null or not. Remember in the AutoML review, there was just a column that said missing values. Here's the code for that, right? Let me go back here and do more of those examples so that you could kind of see. When it showed me in AutoML, when I clicked on a feature and I saw the standard deviation, the mean, the mode, those sort of basic statistical things. This is the code for that, data.describe. Let's see. So yeah, this looks pretty good. I can use this, right? I can use this. And then I also thought that what I would do, I want to show you this. Typically, when I would copy my previous code that I'd use in a previous notebook, I'd have to go into the code cell. I'd have to replace whatever that first feature was and put in digital. I would have to put a value in for X, a new value in for Y, which is here. I have to go into and put in television here and sales. I have to hard code right in my, type in newspaper and radio. I have to do all of that for each thing that I wanted to do, right? And it did it for me, right? If I wanted a box plot, I love a lot of visualizations in my notebooks. And so I am so thrilled when I discovered this late last night that I simply had to just give Bard an instruction and it would use my features. And I could just copy this code, which is here, to my notebook. So all those wonderful plots here. Okay, so I'm going to go back to my deck. So yeah, I was very, very happy and surprised to know that I can save more time using generative AI with code generation. And so I even thought I would try it with building the Keras model. And so I said, build a Keras Sequential API model for me. The features are digital, newspaper, radio, TV. My target are sales. My model architecture is a simple linear regression model. My activation function is ReLU. Now, I tried this several times. I tried it where I just said, build a simple Keras sequential model. It was fine. But when I gave it more of my information, I was very, very happy and very, very surprised to find that it took my features, it put them where they should be, it put the target where it should be, it gave me my model architecture in terms of my number of layers, for example, and it also put in the activation function that I mentioned as well. And I took the code and I basically did a few more tweaks and I was able to run it. So let me show you what the code looks like. But again, just before I go back, I just want to say that what I discovered last night is very powerful when you're coding. I would encourage you to start experimenting with any chatbot out there. Start giving it instructions with your features, what your model architecture is. If you want to go that deep in terms of what activation function to use, so that you get some baseline code that you can just kind of go in and modify. So now I'm going to go to Colab and show you the code, and I'm going to run the notebook. This one's called Predict Sales. It says my runtime is disconnected. It just means that I've been idle for a while, and there's a lot of resources that are being used when I'm idle. So I'm just going to reconnect here. Okay. So if you haven't heard of Colab, I encourage you to actually try this out. Colab Enterprise is free. And I discovered it about, 5 years ago. I've been at Google now 4.5 years. So yeah, it was about 5 years ago. Before Colab, I in order to code in Python and play around, I would install Anaconda. And then I would, deal with the dependency issues. If I had any, if I was on a Mac, I could do, I could also run a Docker version of, it was just, let me just say, when I discovered Colab Enterprise, it changed my life. Because when you're just starting out and you want to learn Python, you need to use Colab Enterprise. It has all these tutorials on Python, but more than anything, it's completely free and there's nothing to install. And you don't have to sign up with your email. You don't have to, it's completely open source. You just go there and you just start playing around. And you can save your notebooks to your drive. You can save your notebooks to GitHub. You can even say save as GitHub so that it opens in GitHub, so that when you save your notebook in GitHub, there's a little banner that says, in GitHub, it says open in Colab. And you're like, yeah, that'd be so cool. Well, it does. So again, I am a really big fan of Colab Enterprise, particularly for people, who just want to get started and playing and learning. You just need to check it out. Okay. So my pitch for Colab Enterprise. And this is just, it's colab.google.research. Again, nothing to install, nothing to pay, no subscription, no email sign up, nothing. It's just always there. And it offers support for both GPUs, graphical processing units, and TPUs, which are tensor processing units. And so you can do some heavy duty, data training, machine learning training using it. So again, please try that out. So this is the same use case that we saw earlier using AutoML, but now it has to be different because we're coding, right? So in order to predict sales using Keras, we're going to have to prepare our data. That means cleaning it. If we have outliers or missing data, we've got to build a model architecture. We've got to compile the model. We've got to train the model. We've got to evaluate the model. And we've got to make predictions of the model on the model. Well, you've just seen using BARD or any other, LLM, large language model. I gave it a prompt. I gave it an instruction, and it pretty much gave me everything that I needed right here. And again, before, I used to get my prior notebooks that were really, really good from a coding perspective, and I'd have to change my features that I was using, the new features, to kind of modify it. You saw that with generative AI and code generation, it did it for me. So I'm going to go now to the notebook. And here it is. I've obviously added titles and that kind of thing, right? So this is simple neural network using Keras. The notebook's called Predict Sales. This is Colab. Just a quick introduction. Again, it's completely free. I keep saying that, but I'm telling you, it is a life changer. You can upload your notebook. When you do load a file here, just know that it only stays as long as you're in session. So you might want to have your data file stored in GitHub so that you have a path to that you don't have to always have to upload it again. Let me show you I'll show you what that looks like when we get to it. But anyway, you can just upload a file from your desktop or make a path to cloud storage or Drive. So basically, here it is. Import the libraries. There's the code. Okay, I added some comments, right, so that you could see it. I can share the notebook. I can definitely share the notebook. So I've added some comments to the code, right? So I'm just gonna scroll down here. Import my libraries, which again, pandas, numpy, matplotlib, seaborn, sklearn. And in order to build a network, I need these libraries. I need Keras, Sequential, and my layers. And now here's what I was saying, I could have uploaded a file and have it here, but so that this notebook always is ready to go, I have a path to GitHub where my file is stored. And this is the file from the LinkedIn Learning course. It's the same file that's also used in the book, but it's the advertising _ 2023.csv. So that it's good. So let me just go ahead and I've already ran it again. I'll just go ahead and run it so that people can see that this is working. So I'm going to execute the sale. Again, Jupyter Notebooks, free. Scroll down. I'm going to run the cell where I loaded my data set. Here, there's my data frame. When you're loading, I know this is not a Python class, and I heard during the intro that you have a Python Python sessions. And so this is familiar to you, but I'm just, for those of you who are new to this, here I have a URL. This is my path to my, that sounds great. So I won't run, the code's already been run. So what I'll do is just kind of scroll down to show you that all the things that I had that was generated, like the scribe, for example, there it is. The shape of the data frame, the exploratory data analysis. Here are the plots that were as a result of that code. And thank you, Kirthikka, because I love this stuff, and so I tend to kind of go on. So I appreciate the time ping, if you will. Another correlation matrix, and which basically is saying that radio and sales, are highly correlated. Keep going, keep going. More visuals, as I said earlier. I love my visuals, but I'm going to get down here before I stop to the model. You can all see this in the notebook when you have a moment. And I do want to spend the last piece talking about the model. Here is the Keras model. And again, 6 lines of code. And then it's trained, right? And then we have our visualizations of that training. And this is what we want to see. Of convergence, a nice little curve down with the training and validation. So let me quickly go here and okay, so there's the code. And if you want to learn more about the neural network and how it works, these slides are part of the LinkedIn Learning course called Introduction to Neural Networks. And so that's where you'll find this information. I basically walk you through what everything means in that course. And so you'll see these slides in that course. So let me go back here. So we did the same thing in AutoML and also using Keras, right? So let's look at the predictions, or the evaluations rather. Here, my root mean squared error, which was my objective metric to evaluate my model, is 0.15 using AutoML, right? Look what it is in the Keras output. It's really 0.14. That's pretty close. That's pretty close. So you saw that it took me maybe less than 5 minutes to load a data set and, look at some of the stats on the features, train the model. If I waited a couple of hours, I would have it, but I'd be done. You saw the code just now that it would take to get to this state using Keras, which is actually low code. So AutoML is very powerful. And I think you can see that the comparison here is really, to me, negligible, right? And so let me go here. So lastly, to finish up, so when to use AutoML and when to use custom training. So you use AutoML when you have, you don't know Python or a lot of the ML concepts or knowledge, and that's fine. You just need it to get a baseline metric. The development time is fast. You have limited flexibility in your models, but you saw that, with AutoML, you could bring in images, audio, video, and tabular data. So that's still quite powerful. But you do not have control over everything, right? And you have really good accuracy. When you code everything, you do require, it requires rather a higher level of expertise. That means that there's more development time expended. You have more flexibility in the models that you choose. You have more control over your training process, and you have excellent results. But we saw that our results were very close. So basically, you can, by using AutoML, believe it or not, you didn't have to code any of this whatsoever. And if you were to use non-AutoML, you'd have to code all of this, no matter even if you use the Keras Sequential API. You could still make it more powerful by using hyperparameter tuning. So, and that's my presentation. Hello?
Yeah,
Oh,
it was a
I didn't, I was just, go ahead.
it was a delight and highly informative session that we had today, Professor. So before we dwell into the audience question, I just have my own curiosity to know more about the Vertex AI tool and the low code and no code AI tools that we discussed today. Like technical strategy is highly important, though it is correlated to the organization's maturity level. I understand Vertex AI has lot of customers starting from GM, Wendy, and many other customers who are using Google Cloud and Vertex AI, who are also using Gen AI for their own application purpose. So what are the basic requirement or the things that they look for when you have to choose a low code or a no code tool?
It really depends, Kirthikka. I think any solution that you choose, regardless of your tooling, has to start with your business case and your problem definition, and that will lead you to your data that you're going to be using. And then you need to decide how you're going to implement that use case. So if your question is, do I start with generative AI first, or do I start with machine learning first? It's going to depend on your business strategy and your ultimate business goal.
Okay. My question is what is a kind of AI tool and no code or low code AI tool that I would be choosing for my own business, and how would I strategize that? Because as a business owner, I am not aware of the data pipeline details. I'm not aware of the in-depth technical details. Instead, I have a business case to be solved. It might impact me if I have to take a non-robust solution. So how do I address that constraint?
Well, okay, so speaking from an AutoML perspective, say I'm a small business owner. I've been a founder of a startup, a small, and I know the constraints, right? I do know that if I could use an open source AutoML tool such as AutoKeras, AutoPyTorch, AutoSKLearn, I would, but I also know that those tools do not provide me a GUI, so that if I have junior assistants that I have to say, can you give me some baseline metrics, I would have to teach them and get them up to speed on how to use AutoKeras or AutoSKLearn or AutoPyTorch. So the only AutoML tools that are GUI based are from the major cloud vendors, right? And so if your goal is to get up and running very quickly, I would suggest you focused on a GUI based AutoML tool.
I think you answered, Professor. So we have few questions from our participants. One question is how do you see no code, low code working to democratize data analysis? If so, how it is going to happen?
I think what you've seen today is, these two junior media analysts were able to just go in and load a data set, click a few buttons, train, and then they have evaluation metrics. They could then provide those metrics to the team, and they've suddenly added a lot of value to the team. It would take a data scientist to do what they did in, for example, 10 minutes, if you exclude the training time that's happening on the back end. So what it's doing is it's allowing people to go in and learn machine learning using a graphical user interface. And if they want to learn more, they want to kind of go, well, I do understand how this works now. I know what supervised learning is. I know the difference between that and, unsupervised learning. I do want to know a little bit about coding. Well, okay, I'll do Keras. But they don't have to even go down the Keras or the PyTorch or the TensorFlow route. They can stay right there and they can load in all kinds of data. And using a GUI-based approach. At Google, for example, we have GUI-based tools for prompt design. We have a product called Model Garden. You go in, you select your model, you do all these things and everything's hosted for you. The democratization comes into play where you don't have to understand and remember every single line of code or how something is supposed to work. You don't have to go in and create the infrastructure from scratch or even understand what you need. It's just there. You just have to go in and start playing and learning. And so that, to me, is where the democratization is occurring, is the fact that someone else is hosting this wonderful playground of all these fantastic tools. And all I have to do is walk across the street and start playing. That's democratization. There's no big fence around the playground. There's no entry fee around the playground. There's lots of open source tools out there. So this is the perfect time, if you're in your career or you're starting out, to pivot into this field, because it has never been so easy to get started, right? Let me tell you, I could give you, when I had to walk in the snow 20 miles speech. I won't give you that speech, but I can tell you, this is the best time to get started in this industry.
True, Professor. The platform architecture is already defined for us, and we don't have to struggle much to understand architecture and to do like data pipelining and things like that, as well as the pre-processing and exploratory is as well, which is well defined before we get into the model building process. So I think what the question is like, the next question is closely related to the previous question that was asked. So it seems that some information or knowledge about the data space is still needed. So what you have explained is about the model building process where we don't have to depend on the architecture, but the participant is more concerned about the data space, like how far is, or he or she must be aware of the data space before getting into these tools.
I think you can pretty much start wherever you are in the data space. You have to remember that there's all kinds of data. I would always start with structured data, right? Always start with structured data. Don't try to boil the ocean with thinking about unstructured data, and just say, okay, I'm just going to focus on structured data. I'm going to learn what that means. I'm going to learn how to use predictions on that data. Just stay into, find one piece that you can kind of really understand and work your way through it. It does take, you definitely have to put in some hours, right? You can use AutoML and not know a thing what you're doing and just say, okay, here are my metrics. And I know that R squared should be closer to 1. Oh, that's great. But if you really want to understand it, the tools are there. There's never been a better time to learn. Just stay focused on one big piece. Don't try to take the whole branch. Just kind of take little bites as you go and just keep adding to your knowledge. I hope that explains, or at least gives you my suggestion.
Yes, Professor. So one more question is like, does Vertex AI supports multiple model deployment?
Yes.
Because okay. We are excited and we are thankful for your presentation. It was highly informative. We got to know much information about the low code, difference between the low code and the no code initially, and then the way that we need to deploy, and where does the concentration from a user perspective as well as from the business owner perspective to be laid on, so that we need to get or derive the profitability from the business use case that we are going to solve. So this is enlightening session for us, and I think the audience are going to be highly benefited with this session. Thanks, Professor, and we wish you all a happy New Year and a happy vacation forthcoming in the forthcoming weeks. Also, we wish to collaborate in much more fruitful session with Women Who Code.
Well, thank you so much. It's been a pleasure. Enjoy. Have a great holiday season.
Thank you.